Hello students, welcome to GATE Academy. So GATE 2020 Instrumentation Engineering, the question is from the topic sampling and the subject is optical instrument and communication. So this is a memory based question and the question is a sinusoid of 10 kHz is sampled at 15 kilosamples per second. The resulting signal is passed through an ideal low pass filter with cutoff frequency of 25 kHz. The maximum frequency component at the output of low pass filter in kilohertz is. So now in this question we have to find the maximum frequency component present in the output of low pass filter. Generally in this type of question they ask about the number of frequency components that is present at the output of low pass filter, but this time they asked about the maximum frequency which is present at the output of low pass filter. So let's see what would be the solution. So in this question it is given that message signal frequency, because it is a sinusoid, so the message signal frequency is 10 kHz, and because only one frequency component is present, we can say that this is a single tone signal and the sampling frequency is 15 kHz and the cutoff frequency for low pass filter is 25 kHz. So the frequency component that is present at the output of low pass filter, so that can be calculated by the spectrum. So the spectrum of sampled signal is given by ms of f is equal to fs summation n equal to minus infinite to infinite m of f minus nfs. So this is the spectrum of the signal, that is the sampled signal. If we take the Fourier transform of that signal, we get ms of f. So now the frequency component, so the frequency component present, in sampling of single tone signal is fm, fs plus minus fm, 2fs plus minus fm and so on. So there are infinite number of frequencies that is present. So let's find what are the different frequencies. So these are fm, which is 10 kHz, fs plus minus fm, which is 15 plus minus 10, that means 25 kHz, and 5 kHz, and 2fs plus minus fm, that is 30 plus minus fm, that is 10. So we get 20 kHz and 40 kHz. And if I calculate 3fs plus minus fm, then it is 45 plus minus 10, which is 35 kHz and 55 kHz and so on. So these are the frequency component that is present in the sampling of the signal. So this signal is passed through a low pass filter and the low pass filter is having a cutoff frequency 25 kHz. So this low pass filter will pass all the frequency component which is less than equal to the cutoff frequency. So a low pass filter passes the frequency which is from the 0 to the cutoff frequency, and above the cutoff frequency it will reject the frequency. So the cutoff frequency for the low pass filter is 25. So the frequency component which is less than equal to 25 will pass. So this is 10, it will pass through the low pass filter. This is 25, this is equal to the cutoff frequency, that will also pass through the low pass filter, and it is less than 25, so it will pass through the low pass filter and it also pass through the low pass filter. So the students may do the mistake that there are 4 frequency component which is passing through the low pass filter, and because this is a numerical answer type question, sometimes the students may think that they have to find only the frequency component that is present at the output of low pass filter, and you can substitute the answer as 4, but this is wrong. The question you have to read carefully, that the maximum frequency component we have to find, the maximum frequency component we have to find, not the number of frequency. we don't need to find the number of frequency component present at the output. We have to find the maximum frequency component that is present at the output of low pass filter. So if I ask you what are the different 4 frequency component present at the output of low pass filter, then the answer would be 5, 10, 20 and 25. And if I ask you the maximum frequency component present at the output of low pass filter, so the maximum frequency will be the maximum of these 4, and the maximum of these 4 is 25. So the maximum frequency present at the output of low pass filter is 25 kilohertz. Okay, so we don't have to find the number of frequency, we have to find the maximum frequency, and the maximum frequency is 25. So the answer would be 25 kilohertz.